Thanks so much. Thanks also for hosting us. I think it's quite a cool thing that you like invite such a large crowd into your office space, and I think that's a great thing without that this in-person meetup wouldn't be possible. I'm going to talk also about LLM Inference, about some open source engine. Doesn't mean that TensorRT LLM isn't open source. It's new in the game, and I started contributing to 3 of them: CTranslate, VLLM, and TGI. If you don't know them, I hope this gives like a short intro to that. That's me. I'm a machine learning engineer. I'm originally not from Munich, but I did my master's here. I'm more or less active on GitHub. And if I don't build like my own inference engine from scratch, which is this one here, quite interesting thing, would partially recommend. Then I also contribute to a bunch of open LLM inference engines. And I just wanted to contribute to basically all of them, but in the end, I just ended up with these 3 for now. Let's see what the future brings and what the time does. This VLLM did like actually the first PR on this repo ever. Also converted Starcoder, which is basically I knew it from Mustasham, and figured out, okay, could actually run this a bit faster, then converted to CTranslate, got featured there, translated also in VLLM and so on. And it's quite nice actually starting basically a bit from this meetup here actually. So the slides are obviously you can get them in the end, no need to take photos. They are under Apache 2.0 like most of the things I do, and excluding of course it's 2023, there's some stuff that you can't read, so attached with some strings, and these are my own slides, personal view. Don't sue me for it. Like half a year ago, if you used the internet, there was a great talk. It was from Andrej Karpathy, and he talked about the Cambrian explosion of large language models and how Llama 1 whole ecosystem blow up, so many models, fine tunes. And I'm going to talk about the Cambrian explosion of LLM inference engines. And we measure that in GitHub stars, as most of the things, most of the important thing, GitHub stars, obviously. And it's quite a journey. If we look at, for example, CTranslate, what I mean with like Cambrian explosion, it's been sitting there, all the stuff was implemented, a bit used for like natural translation, that's where it's originally from, that's from this NMT group. And yeah, it was waiting there until basically all of a sudden we got this thing falling down, and then also Llama dropping, and then all of a sudden this thing exploded. There's also other repos, Llama C++, if you heard of them before, and things are just rocketing, and I can't even put like the GitHub stars on this metric here because it would just be off the charts. Yeah, the question is, like, we have PyTorch, we have TensorFlow, why are we not using them directly? Why are we building so many frameworks around it? And there's a bunch of simple answers to that. If we just look at the size, some parts of that were not really fun to do, especially if you're like a person getting new into the space and say, can I run this thing on my 2017 gaming laptop computer? This was really not fun to do, because previously you could do that. You ran BERT large, you downloaded 0.3 billion parameters, not too much, and you just do the inference, 0.6 gigabytes. And then we had Llama 1, and Llama 1 is just massively bigger, and there's even larger ones in the open source also, and 216 times more everything. You had download, you had RAM when you load it into GPU. At GPU also, the RAM is kind of expensive, as you guys might have heard. And there's also this forward pass cost, I would say, abstractly, and everything just gets more expensive, and you want to have the only thing that is really basically all that matters is it needs to run fast. And the other thing is what you've previously also seen, I think in the previous 2 slides, was this, like, we have this decoding. So you have your classic machine learning model, you have this image maybe, and you put the forward pass on it. And then you have some probability from it. But in language models, you just get one token, your next token. And you obviously want to run this chatbot, and it generates a lot of tokens in a row. And so what you need to do in Python is to do this ugly thing, for loops. They are slow, and you have like here maybe 10 next words that you tokens that you want to generate. And this is not the code that is actually running. So it's just like some sample code. You have this argmax, for example, just greedy sampling, and you append that. And that's also a really ugly thing to do. You append to something, and next time your forward size pass basically of your thing is growing, and it's all getting a bit annoying. And that's not even the whole story. We heard there's like attention improvements, there's key value caching, which is also growing your pen to vectors. And this is horrible, everything in Python. In terms of speed, you can do that. All of that you can do all of that thankfully with things like PyTorch and TensorFlow under the hood. But it's so much boilerplate code that even there's a whole library who does just, instead of LLM forward, they do LLM generate, and they call like Hugging Face transformers. If you use them, they pack this into a really nice API, and that's what basically makes LLM inference a bit special compared to most of the other machine learning models that you used. So now coming to C-Translate, there's also Llama C++. It's quite similar to C-Translate too. And the crazy thing, what they do is they say, okay, we have Torch, we have TensorFlow. Let's throw all that all away. Let's use directly like some CUDA stuff, 1D and MKL. Let's also throw away the backward pass because we don't need it anymore. It's just inference, right? And the second thing is here, which was the crazy step, is say we go to Int4 models, for example, and we directly upload them, for example, on Hugging Face Hub. So basically the people with their old gaming computer under their desk, they would then go to Heise Online, read about this great new model, and then they would somehow try to download it. And of course, if you have like just a fourth of the size, awesome, you can download it directly. And some of these things are also implemented. Fast caching, definitely a graph, fusing some kind of activations. It's also possible, and sometimes also they have like flash attention improvements. And yeah, this is basically why it got famous. It can run on this machine under your desk to some degree. They support streaming of that, so it's good enough for one person basically to run on your local computer. Just worked, basically no long steps to compile anything. It was just like most of the things are pre-built. The basically file you download, it works directly on your local machine. And it was just a game changer. In the beginning, you would spend days and hours, like in February, like all the frameworks that existed back then, they were just horrible to use. Like the user experience was just days of like trying to figure out why something didn't work. There's also some kind of limitations when it comes to like C-Translate, but also applies to Llama C++ to some degree. And this kind of my own computer kind of deployments, it's usually good for like one GPU or your like local sets of GPU. It's not really good at this like tensor parallel of like you have multiple kind of GPUs around and do things with that. And it's designed for one user. And the main limitation is because it's basically one of the first repos that came up with this in the open space was this TGI, text generation interface inference from Hugging Face. And what they do is basically do this one. You have, for example, here in this case, you have 4 users. And these 4 users each want to have their own chat running, basically. It's no longer people that have their own hardware. It's people who are just visiting chat.openai.com or something like that. And they all want to have their prompt. And their prompt is going to take different amount of time. They have like different expected lengths, basically. And for example, user 2 comes with a very short prompt, and he wants to generate a lot of tokens. So what will happen if you do like this static batching, this user 2 will like block the entire GPU for the entire time, and there's these white spaces, basically where the GPU runs at max batch size and it's sitting around idle. It could do something, it could process the next guy, but indeed it waits until the last person is finished, and that's happening also in C-Translate too. And basically the resources are not really freed up, and you could do better. And they announced in-flight batching, continuous batching. Different repos have different names for that, but it all does the same. It does basically this thing. As soon as like while person 2 like is still running, they say, okay, here's the next person, and go through it. And what they do is basically they say, okay, we have these 4 people coming next. They get 1 token, each of them generated, and then they go all back to somewhat, and then they go round robin and say, okay, now I have the next 4 people coming up, and they batch them in there. So you have these 4, and everybody is basically happy to this degree. And there are some fancy things going on with page attention and caching, which I will not focus in this talk. It's just too short for that. But basically, it's reusing some parts of the cache that is happening there. And what is kind of the most interesting part is contributed to like VLM and also TGI, some parts, is that actually, from a system design point of view, all of them are identical, and they are all written in different programming languages. So if we have this kind of prompt, a user, basically web interface, JSON, API, whatever you want, is basically a server, and you have this kind of engine under the hood. So if you send this request, it gets here, it gets validated, then it gets to the engine, and the engine says, okay, perfect, I'll tokenize that. And then you have send it to something that is like the mastermind in all of this. It's like the scheduler, and the scheduler decides who's next, who like which 4 guys will I put on the GPU next. And it sits around with these tokens and it's been waiting. And there's also like different, for example, Python does all of this here with like fast RP front end, and then like Python here and Python here. TGI does it all with like here some Rust code here, and again here Rust code. And also TensorRT LLM uses Triton here, and then this batch manager, I guess, under the hood here. But it's, don't kill me if I got something wrong. It's just a similar kind of approach, and interesting. Yeah, this is basically the way to go now for this inference. And just to keep in like VLLM kind of terms, so you have this scheduler, and the scheduler says, okay, these 4 people go on the GPU up next. You have these ones running here, waiting, and you have probably also the workers. So this thing doesn't use your GPU, doesn't have the model. And this one says, okay, these are my 4 next people that go on the GPU to generate the next 1 token. So you have this worker, and under the hood in the worker, there sits this model. It's probably this Llama model. It's the PyTorch stuff that is loaded from disk. And it performs this one format pass on these 4 sequences of tokens, and then gives back the results here and streams it to the user. And what happens simultaneously, also some caching. So there's also cache management, which I blurred out in this one, but you have also some caching that is happening directly on the GPU here, especially when there's like this KV block, which helps you to basically not recompute some stuff that you had previously computed. And then from here on, you go back to the users. This is why you see ChatGPT writing like in this funny streaming thing, is because the rest of basically your query is still sitting on the GPU somewhere on some server, streaming the results directly out to you to minimize the latency. You don't have to wait for the whole query to be answered. And the rest is just going back to the scheduler. So if your prompt is basically not finished yet, if you didn't produce end of token, goes back to the scheduler, and you do have, back at the scheduler, and it's like basically equal to all the other batches that you have. And then the scheduler says, okay, these 4 are up next, go to a forward pass. That's all from my side to engines. And in this in-depth view, let's see what I see is probably going to come up next. There's actually batch LoRa inference. So it's something that's probably, I can't tell you really what is up in 3 months or in 6 months. It's probably happening in the next 1 to 2 months, I would say. And the reason I see that is a bunch of companies already have that, basically proprietary. And it's already on the roadmap of several like open source engines. It's basically this idea of, I have multiple models and I want to fine tune my model, but I don't want to have like pay for a server that is running 24/7 just for my one inference. So what you can do is, if you know this kind of paper here from LoRa, they say, okay, we have our own weights, and then I have my small tiny adapter, a couple of megabytes, and I plug it in and I run this thing in parallel and this thing here batched. And that would be also super cool idea. If you watched like the OpenAI Dev Days, I didn't, but they apparently announced something like fine tuning. And the idea is that you have like GPT-4 and you can fine tune your model and put it into a store and other people use it. You can sell it at some point and make it say, okay, you can use the model I fine tuned on GPT-4 or something. They will not deploy GPT-4 just for you. It's probably like 64 GPUs. You will not get that for like 5 cents. And what I'm also proud of, this Gradient, this is like my future employer. And they already had that like 1 to 2 months previously in the public product, and now exciting where the journey goes here, and also excited for a second part which is called speculative decoding, which hopefully runs when I press this. Yes. So we have this quick brown fox example, for example, and we have this assistant model. And the system model just generates a bunch of potential candidate tokens. And these candidate tokens go back to the language model, and then you can run batched inferences on all of these previous tokens. You have this token selection, and this will run basically a good amount of faster, like maybe 2 to 4 times here in this case, roughly speaking, or 3 times maybe. So this could be quite nice. Actually opened also in TensorRT LLM the issue for that, hoping that it's decoded, like anybody should support it pretty soon. And it's going to be exciting times, especially if you think about something like in your IDE, when you complete code like GitHub Copilot, this thing is a game changer. Would be also quite nice to have. Also a reason maybe why GPT-4 runs at lightning speed, even though it's probably pretty big. Nobody knows how big, but rather big. Back to the beginning, Cambrian explosion of LLM engines. Yeah.
Sorry, when we asked, why would this be more efficient to have this assistant model before?
The question is not like why it would be more efficient. The question is basically why it would be faster. And the reason is you have this very small model. It's like, if this is like StarCoder 16B, this is just tiny StarCoder 100 million. That model really exists. And you run these 4 tokens here. And that, imagine it takes just milliseconds, like no time. And then you put these 4 candidate tokens in there. You can basically treat it like 4 different users putting 4 different like tokens. You just need to generate 1 more token for each of them. And what happens then, you generate these, you have like, it's like 4 different users, each want to generate just 1 token. And you can just validate if it's correct. So if you say, okay, Fox was apparently the first one, Jumps was right, and Into was wrong, then you generate it with this 1 forward pass, which takes a lot of time, which what you want to minimize, just generate one more token. So basically it's, you do the same computations to some degree, but it's just faster because of this batching, because of vectors that are vector processing improvements.
In an average sense, I would say if you still have to run the large language model in the second pass, so where's the advantage of it?
Okay, you run this thing here, you have 4 tokens generated, and you run this only 1 forward pass with batch size 4 instead of 4 forward passes with batch size 1. And because you can batch them and put them into like multidimensional vectors, if you multiply them, that is a faster multiplication on hardware accelerated hardware. Yeah.
You can
parallelize some
those 4 passes instead of having sequential.
Yeah, because you basically know the future, so to say, or you assume you have it. It could be also it could be actually also slower if you have a terrible model here, random model. Or if you have like a high temperature, which is just basically cyclically almost a random token next, then you can't predict the future. You run a batch size 4 and you realize, oh, all 4 predictions were completely off. I have to discard all but the first one. Then you're kind of slower. You then run useless 3 different batch sizes, basically. But 4, like 3 out of 4 will be useless.
You could have on quality as well.
No, the quality is identical. If you forward pass it with this one, up to numerical position, you validate it. This is just a validation. If it's identical, and if not, you can discard it. So you can make it no quality. That you don't lose any quality on the way.
But the pass point is smaller. That's why.
Yeah.
So that can affect the quality.
Well, it's just candidate tokens, and you validate here. So unless it's the identical match with what you had in mind would be produced, it works.
Okay.
But we can have a longer discussion afterwards anyhow. Yeah, so Cambrian explosion of LLM engines, this was just the beginning of it. There's always huge promotions at the beginning of start of any LLM engines. It's quite fascinating how like social media explodes every time it's new one. There's also, I'm really happy to welcome you guys here with TensorRT LLM, also with a head start. And what I want to say here is basically at any point of time, you will be able to contribute to some of these like repos, and it's great to have it open source. There's a lot of dynamic there, very welcoming. You can open a pull request issue. You can also write a blog post about it. Could be also quite interesting to see. Just get active is my advice. Just yeah, it's super welcoming. If you discuss with them, there's somebody getting back to you, insane energy in this field right now. And this is our closing remarks, and thank you so much.
One question, and then for the rest, we can say after that. Please go ahead and say something.
Here's the slides.
Yeah, the slides, but we also provide the slides in the GitHub page on the Discord you can find.
Okay.
So we have time for just one question. Anybody wants to ask? Okay.
So to stick with the Cambrian explosion and evolution, evolution sometimes also goes back to the older species, and then the older species actually evolves and becomes dominant. I've heard about XLSTM, and you seem to be quite into the jungle of models. Have you heard about that? Can you imagine if the guy who's promoting it can actually nail something with that?
There is, I would say, some other different branch XLSTM. I'm not super familiar with it. I didn't fully get it, but what is nice about it, imagine now you run all these caches and stuff that you implement. You run basically the forward pass, and you have this, each time you do the forward pass and your series gets longer, you have this, the attention with all the previous words that you need to compute. So it just gets like, basically to the power of 2 more expensive to compute the next token. And then what is interesting, there are some architectures like RWKV, and they do like this thing linear, like an LSTM. And that could be quite a breakthrough, but I mean, training a model is like a 10 million thing. And if you want to, if you are like, have the balls and say, I want 10 million funding from somebody, and then put it all in one shot and rent a big data center and then realize it doesn't work, then could be quite dramatic. Yeah.